Hello and welcome. Thanks for joining me for this session on Azure Logic Apps. In the next 30 minutes, we'll talk about what is Logic Apps and what you can use it for. We'll cover a major update that we're announcing and releasing here at Build. And then we'll talk about what's coming up next and how you can get involved. At the end of the session, I hope you can walk away with a better understanding of the capabilities of Logic Apps, but more importantly, to inspire you with use cases and scenarios so that you can give it a try and see how Logic App can help you to accelerate your business. So without further ado, let's get started. And we'll begin by trying to answer the question of what is Logic Apps and why should you care? This is actually a somewhat tricky question. Unlike many other services that we have in Azure, it is not exactly easy to define just exactly what Logic App is for, because you can use it for so many different things. For an integration developer who have been building integration solutions using BizTalk, they may view Logic App as the cloud-native solution for them to build future integrations, connecting systems and services on the cloud, on premises, or both together. For an application developer, let's say someone built line of business applications using Power Apps, they could view Logic App as a great tool to implement backend APIs, which is then used to drive the user experience. Getting data from the backend systems and surfacing that to the user, and then taking user input and push those back to those backend systems. For IT pros and process engineers, they may view Logic Apps as a great general purpose workflow engine. By leveraging its vast connector ecosystem, they can build workflows for things such as DevOps, or automate business processes such as order processing, reinforcement training for machine learning models, and so on. But there's so much more. We have customers using Logic Apps and its ADI capabilities to implement invoice processing that involves the movement of millions of dollars, X12 messages in healthcare setting that involve confidential information in a HIPAA-compliant fashion, or to implement complex messaging patterns such as claim check and sequential convoy. But the team have put a lot of effort in making sure that such rich capabilities are also extremely easy to use. So let's take a look at some of the building blocks of Logic Apps and how you can use it to implement for your use case and scenarios. We can break down Logic Apps into two major components: the Workflow Designer, which is used for the creation of workflows, and then the Runtime, which is used for the execution of these workflows. So let's take a look at each of them. The Workflow Designer allows you to create and author workflows visually without having to write a single line of code. Each workflow always starts with a trigger. It can be a timer trigger, and as simple as running the workflow every minute or every hour, or as complex as running it every 15 minutes, Monday through Friday, between 9 and 5. A trigger can also be event-based, such as triggering the workflow whenever a new message is appeared in a service bus queue or inside the SAP system, whenever a new event is published to an event grid topic, or whenever a new row is inserted into the SQL database. And lastly, a trigger can also be of a request trigger, so that Logic App itself is surfaced as a RESTful API for other services to invoke, such as the Power App example that we just talked about. After the trigger, you can add one or many actions. There are control flow actions such as if-else and switch case conditions. We have loops such as for loop and do until loop. Data operations that allows you to initialize and set variables. Utility functions so that you can parse and validate JSON against a schema. transform data between XML and JSON, or even to parse data and format it so you can send it in an email. There are, of course, ways to define either the parallel or sequential execution of the actions. Remember I said that you don't have to write a single line of code when using the workflow designer? Now, although we don't require you to write any code, you can still do so, and we have a very easy experience when you have such requirements. You can invoke code that has been written inside an Azure function, or you can even write code inline from right within the workflow designer, referencing workflow context. This is great for scenarios such as regular expression matching or array manipulations. And lastly, but certainly not least, you can use Logic Apps to talk to more than 400 services from within Azure, by Microsoft, or from third parties. We all know that working with a service and their APIs aren't always easy because everyone implements their APIs ever so slightly different. How to authenticate, where to specify the version information, and how to pass data back and forth. With Logic Apps, we take care of all that. We even take care of the authentication when it comes to OAuth, and we securely store and renew that information as needed, so you never have to worry about it, which means you can then really focus on building the core business logic using Logic Apps. Next, let's talk about the Logic Apps runtime. The runtime is highly resilient by design. As the workflow runs, the information about each and every single action is being preserved into storage. This means not only will you be able to review how the workflow executed at a later time for either debugging or auditing purposes, it also means that in the event of a catastrophic failure, such as data center losing power in the middle of a workflow execution, once the power is restored, we'll be able to use the information preserved in storage to reconstruct that run and execute the workflow to completion without you having to do anything. The runtime started as a multi-tenant implementation 5 years ago when Logic App first became generally available. But in the last year, the team have been working really hard on a major architectural change to make it into a rehostable, containerized, single-tenant runtime for scenarios such as local development and debugging, as well as running it in a dedicated compute in Azure or even in Docker or Kubernetes environment. We released this new runtime to public preview at Ignite in 2020 and have been working really hard to make sure it is ready for customers' production workload, which brings us to the announcement for the day. Working with several pilot customers in healthcare, insurance, and retail industry, as well as feedbacks from MVP and Azure communities, we feel confident that the new runtime has the feature and quality that's needed for customers' mission-critical production workload. So today, here at Build, we're pleased to announce the general availability of the new Logic Apps runtime. This marks a major milestone for Logic Apps and the biggest leap forward since the initial release of Logic App 5 years ago. So let's take a look at what is new. The new runtime is built on top of Azure Functions runtime. It is rehostable and able to be containerized. It also means that the runtime is now cross-platform, so you can run it on Windows, macOS, or Linux. Local development is possible with the new runtime. You can now create a local project in VS Code, use Designer to author workflows, and execute it with the runtime running on your local machine. With development comes the debugging. We're introducing the ability to set breakpoints to workflow when running locally, so you can leverage the debugger to troubleshoot workflows just like you can when writing code. When needed, you can run Azurite, a local cross-platform storage emulator for the Logic Apps runtime. With the new runtime, it also supports advanced networking capabilities when deployed to app service on Azure, and you will be able to have direct connectivities to services and endpoints inside a virtual network, and with private endpoint support. Many integration account actions are now built in, such as Inline Code, so you can use it in any workflow. XML and JSON actions, such as transform and validate, are also now built in. Customers expect many connectors to be high performant and able to move a large amount of data. The new runtime allows us to move them in as built-in connectors, so they can run in proximity to the engine itself, resulting in a much higher performance. Examples of such connector include SQL, Service Bus, MQ, and we'll be adding more to the list as time goes by. But it's not just for us. You, as a customer, can now also build custom connectors in a codeful fashion and have it run alongside the runtime. We have a detailed write-up on how you can do it yourself, so be sure to check it out. With the new runtime, we also introduced a new concept of stateless workflow. You may remember when I talk about the engine being highly resilient, and that is achieved by us preserving data every step of the way as a workflow executes. This behavior comes at the cost of storage operations and therefore latency. For certain scenarios, such as using Logic Apps to implement a request-response API, using Logic Apps for data transfer, or to process IoT events, one may not need such behavior, and therefore opting into stateless execution model and having the engine skip the step of preserving data to storage, you will be able to realize an even higher performance and throughput. The new runtime also allows us to offer a better, improved DevOps experience, and a consistent one when compared to other services such as App Service and Functions. There are GitHub Actions and Azure DevOps support for you to implement a proper DevOps pipeline with infrastructure as code approach. You can also package the project as a Docker container and publish it to a container registry. Even better, you don't have to figure everything out from scratch. Simply head to our GitHub repository for a simple project with everything already configured to use as reference. And lastly, we figured what's better than a brand new runtime is to include a brand new workflow designer to go with it. So we have completely refreshed the workflow designer with this release as well. We moved to a new designer core that includes a new layout engine to support the ever-growing complex workflows that we see customers are building. We also introduced more advanced rich interaction patterns, such as Canvas for visualizing the workflow and action dependencies, and Panel for configuring input and settings for each action. Drag and drop improvements with visual indicator for drop zones, and the ability to run request trigger with a payload from right within the portal are all things that we think you will like. We also spend a lot of effort to improve keyboard accessibility to ensure that we can empower everyone to be able to use Logic Apps to build awesome workflows. And there are a lot more to come. On the business side, we're introducing a new SKU for Logic Apps based on the new runtime, called Logic Apps Standard. There are 3 sizes for you to choose from, Standard 1, 2, and 3. The multi-tenant Logic App will now be called Logic App Consumption. This gives you, our customers, the flexibility to choose between those two options. Consumption logic apps will still have the pay-as-you-go billing model you have come to be familiar with, charged based on number of actions executed. And with Logic Apps Standard, you will be charged based on the compute and storage resources. Be sure to check out Azure pricing page for the exact cost in your Azure region. Oh, did I mention that we are taking a customer-driven approach and working with pilot customers to make sure we're building the right set of features? I just want to take a moment to thank one of those customers, ASOS, for being on that journey with us. And it is great to see the alignment we have on features customers love, and they are what makes the new runtime great. Advanced networking, DevOps, performance, custom connectors, and local development experiences. We're really talking about the complete package here. All right, that is a lot of new features. So why don't we take a quick look at a demo for some of them? I will be doing the demo from macOS to show you the cross-platform nature of the service. But the experience will be very similar no matter you are doing this on a Windows, Mac, or Linux machine. I will start by creating a local Logic App project. We'll call it Logic Apps Demo. And we'll start with a stateful workflow to begin with. Before I do anything else, I will switch to Terminal and start Azurite. This will be the local storage emulator for the Logic App runtime. With Azurite running in the background, I can then open the Workflow Designer. I do want to use connectors from Azure, so I will choose a resource group for my connection information to be stored at. We'll start by building a very simple workflow. It will have a request trigger, so we can call it from Postman to test, and a response action that will simply return hello world. Let's save the workflow, start a debugging session, and see what happened. You will notice from the terminal output, Azure Function Runtime is starting. That is what the Logic App runtime is built upon. Looks like everything started up successfully. Now, I can open an overview page for the workflow and copy the request trigger URL from it. In Postman, I can just paste in the request URL, make sure I'm doing a post, and hit send. From the background, you will notice terminal output indicating the request has been received and processed. And from Postman, we got a hello world response. Great, so we know everything is working. Let's make some updates to the workflow and make it a little bit more interesting. I will start by updating the request trigger and specify an input schema. In this case, I will be expecting a property called zip code. Then I will insert an action in the middle, and I will use the getCurrentWeather action from MSN Weather. For location parameter, I will reference the zip code value from trigger, and here you can see I'm using dynamic content, also known as tokens, to easily reference the value from a previous step. With the new action configured, I will then update the response action to return the temperature information in the body. Let's save the workflow, start a debugging session, and give it a try. In Postman, I will add a request body, making sure the content type is set to application JSON, and the zip code will be 98052, the zip code for Redmond, Washington. When I hit send, this time we'll get the current weather information back. The next thing I want to show is debugging. If I switch to the code view of the workflow we just worked on, I can set a breakpoint at the beginning or the end of an action. I will set it at the end of the get current weather action. Let me send another request from Postman, and this time a breakpoint should be triggered. Now that we're in the debugger view, we can look at the variables and examine all the properties that are present in the action results. Once we're happy with it, let's hit continue from the breakpoint to allow this request to be completed. Now that we have built the workflow, let's take a look at the DevOps Experience. I copied the file from the sample GitHub action project available on Logic Apps GitHub repository. Here you can see 4 GitHub actions, one for deploying infrastructure as code that includes the Logic App resource, connections, and storage account. This action just needs to run once to set up the infrastructure. Then we have another action to deploy the workflows. This will be the action that runs every time an update is made to my workflows. We also have 2 other actions. Those are for deploying the project as containers. Also included are several ARM templates for deployment and a helper script to generate connections. Again, you need not to do this all by yourself. Please reference to the sample project on GitHub for more information. So let me add all the files to be tracked by Git, commit them, and push the latest change to my remote branch on GitHub. Once that is completed, I can switch to my browser and navigate to the action view of the repository. For testing purpose, I have configured all the actions to be triggered manually. So let's first start the infrastructure as code GitHub action. It will sign into Azure with the credential I have configured, check out the latest code, and start the deployment of my infrastructures. Once that is completed, I can switch to the workflow deployment action, and it will package my workflows in the project and deploy it to the infrastructure resource that are just created. With both GitHub actions now completed, let's switch to Azure Portal and make sure everything works. Here you can see the Logic App resource and the workflow we just created locally in VS Code, now recreated by DevOps pipeline in Azure. But what if I want to get the weather information in Kelvin rather than in Fahrenheit? I know there is a simple formula to convert from Fahrenheit to Kelvin, so let me add an inline code action here for the conversion. And I will update the response action to use the output from the inline code action. And just like that, let's save the workflow and test it. I will retrieve the request trigger URL from the overview page, paste it into Postman, and hit send. Just like that, we're getting the weather information back in Kelvin units now. I hope you liked the demo. So how can you try it out? Well, you can go to Azure Portal today to create a new Logic Apps standard resource and start authoring workflows from the web. You can also download the VS Code extension for Logic Apps standard and check out the new local development and debugging experience. Then take it from there to try to integrate with GitHub Actions or Azure DevOps to be able to deploy that local project into Azure. You can also try out rehosting it in a containerized environment on Docker or on Kubernetes. And while you're doing all that, remember to check out the new high-performance built-in connectors. They're now available to all inline code action. Maybe try to create a codeflow custom connector, or see if Stateless Workflow is for you. As for what's coming up next, we have a lot planned. We're committed to make continuous improvement to the runtime to add more features you are looking for, as well as support better integration no matter where you want to have the runtime to be, locally, on Azure, or Arc-enabled Kubernetes environment. For the designer, we want to make it even easier to use, with responsiveness, rich gesture for you to interact with the elements in the workflow designer, as well as smart recommendations so you can find what you're looking for in building the workflow. But we also want to hear from you. What's important for you? What feature do you want or need? Please let us know. You can find us on Twitter at LogicApps.io. We are also present on YouTube with video tutorials and regular webcasts. So be sure to tune in and interact with us. We're also working really hard to make sure we have great documentations so you can find the information you are looking for. So be sure to check it out. With that said, it is time to end. I want to thank you very much for watching and see you later.